Hi everyone, today let's solve a Leetcode question called maximum product subarray. So in this question, we're given integer array nouns, and we want to find the contiguous non-empty subarray within the array that will give us the largest product. Example 1 here, a number is equal to 2, 3, minus 2, 4, right? If we pick 2 and 3, and we have the largest product, 6. And if we pick any other numbers, whether it's single element or multiple elements, we cannot get a product that's greater or equal to 6. So we just return 6 as output. Example 2 here, we have this number including minus 2 and 0 and minus 1, right? And you see if pick any single elements, the maximum will be this 0. And if pick multiple elements, since we have 0 in the middle, the product will always be 0. So the result should be 0. Okay. Now finish the quick problem introduction, let's think about how to solve this question. So in this question, we're using a variation of the traditional dynamic programming approach. And let me show you how it works using example 1 with graph drawing on the right side. So for this question, we have array, for example, 1, 2, 3, and minus 2 and 4, right? And now we have to consider the strategy for updating our current maximum and current minimum and the results in the dynamic programming approach. And the first thing we consider is let's say current maximum is maximum. If both maximum and the current number, let's say n, are positive, then maximum multiplied n will give us the largest number, right? So this one is definitely what we have to consider. And the other thing we have to consider is if the current minimum and n are both negative, then the current minimum and will give us the largest product. So this also we have to consider. And the final, then we have to consider corner cases. So for example, we have array that do like this, 1, 0, 2. You see the largest value, these 2 lies on the right side to 0, right? If we still calculate using maximum multiply n or minimum multiply n, it will give us a 0. This is what we don't want. So for this scenario, we want to reset the current maximum using n itself. So also consider n itself. So these are 3 scenarios we can consider. And for all these 3 scenarios, if we find the maximum value, then we get the current maximum for the next iteration, right? And if we take the minimum value between these 3, we get the current minimum for the next iteration. Okay, now finish the illustration of this problem. Let's go through this example. So let me build a table here. Okay. So in this table, we need a total of 4 variables. And the first variable is n, which is all numbers. So just use 2, 3, minus 2, and 4. And then we need the maximum and minimum, right? So they are both initialized 1. I don't write here. I just say some space. And the result should be initialized as minus infinity. So just use a different color. Okay. Now the current point is set at 2. And the maximum and minimum should both be 2, right? Because so far it's only one number. And the result should be set from minus infinity to 2 because 2 is greater than minus infinity. Okay, now let's move this pointer to the next number 3. And for 3 here, we have to follow this strategy, right? So let's do the calculation at this part. You see maximum multiply n should be what? Should be 2, right? Because previous maximum is this 2. And the current n is 3, so multiply this one, again like 6. And minimum multiply n should also be 2 multiply 6, and also be 6. And this n itself should be 6. Now I want to take the maximum and minimum. You see the maximum between 6, 6, 3 should be 6, right? So write 6 here. And the minimum between these 3 numbers should be 3, so write 3 here. Now the result should be updated from 2 to 6 because you see this 6 is greater than this 2. So write 6 here. Okay, now let's move the point further to the next number, which is minus 2. So just cross this computation out. And for minus 2 here, you see the previous maximum is 6. So 6 multiplied minus 2. which will give us minus 12, right? And the minimum, you see it is 3, and multiply minus 2, this will give us minus 2. And any cell should be minus 2. And you see the maximum between these three should be minus 2, right? And minimum between these three should be minus 12. And the result should still be a 6 because this 12 is smaller than this 6. Okay, now let's move further to the next position, which give us n equal to 4. Okay, so just cross it out and redo the calculation. So see, at this step, the maximum multiply n should be minus 2 multiplied by 4, right? But minus 8 here, and this one should be minus 12 multiplied by 4. It should be minus 48. And n itself, so it should be a 4. And you see the maximum between these three is this 4, right? So I have 4 here. And the minimum between these three is minus 48, so minus 48 here. And finally, the result should be still 6 because this 4 is smaller than the previous 6. Okay, now finish the entire search. You see the final result is 6, right? So the only thing we need to do is to return this 6, and we're done. Okay, now finish the graphical explanation. Let's dive into the coding part. Okay, so as mentioned in the graphical explanation, the first thing you set the minimum and maximum. So just use current maximum and current minimum. So both as 1. And then set result as float minus infinity. After that, want to traverse all nouns, right? But in range length of noun. And you see the current minimum in between minimum value, current maximum multiply n, current minimum multiply n, and n itself. And current maximum means the maximum sign. Let's copy paste here and write it here. And finally, the result should be the maximum between the previous result and current maximum. And then we return the result. This strategy has one shortcoming here. So you see at this stage, right? This current minimum are using the previous current maximum. But after we update the current minimum here, this current maximum is actually using the current minimum at this stage, right? Because we have a do update at this line. To avoid this scenario from happening, we have to record variable, let's say is temp maximum. So this temp maximum is current maximum multiplied by n. So we get the previous current maximum multiplied by n at this temp maximum. And then also record the temp minimum. So like this form, right? And now we can safely replace all these variables. And finally, let's run the code to see it works. Oh, sorry. Oh, it should be for n in nouns. Okay, let's resubmit the code to see it works. When you see the time capacity memory usage of this solution quite efficient, right? I think the code is short and easy to understand. If you like this video, please subscribe to my channel, and I see you next time. Thank you.